Yes guys, welcome back to Pure Math School. Last time we had a look at the introductory work, the first part, the number line, and today we're going to look at inequalities. And about what we need to know about inequalities, we need to be familiar with the following. We need to be familiar with this. And this. We also need to be familiar with this and this. That's the first things we should know, and we need to know what each one of these four inequalities mean. I'm starting with this. For the case of this one means A. This sign is used to mean greater or equal to, greater. This sign here means greater than. This other sign here means greater than or equal to. This one down here means less than, while this one else means less than or equal to. A and B are just numbers which would be integers on a number line, and now if we interpret each of those, we mean that A, since we mean this means greater than, A will be greater. A is A with that symbol B means A is greater than B, while that A greater or equal to B, A is greater or equal to B, meaning A can either be bigger than B or equal to B. This other one, A, B means A is less than B, while the last one, A, that B means A is less than or equal to B, meaning A can either have a smaller value compared to B or just be as equal to B. Another thing we need to know about this under these inequalities, this and this, I can call this open circle. This one closed circle. This one without an open circle will mean exclusive. You're going to see that later of the number, and this closed circle will mean inclusive of the number. Now today the number line is still going to help us what we looked at last time, but for today we're not going to just be looking at points. We'll be looking at a section across the number line. That means let me draw a number line. That 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5. So instead of looking at a mere point, let me say at -5 here. 95 is a point on the left side of 0. That's by moving 5 steps behind 0. And since I said we are not going to just be looking at at a point, we're going to be looking at a section. That means a stretch from one number maybe to another. Let me say, and we're going to use that with the help of this open and closed circle. So let me take an example of, let me say a -3 here. Let me make it a closed circle, and also another one at, let me say 4 here, and make it also a closed circle. That, so under today this inequalities, we are going to basically be looking at a section like that. So we can interpret this section of which, since we have a closed circle here and a closed circle here, and they are on -3 and -4, that means we are simply going to be having a set of numbers from -3 up to 4. With this closed circle, remember I said that it means inclusive of a number. So whenever you see a closed circle on top of a number, that means you're going to include that number in your set. As well as this side of 4, you're going to include 4 in your set. So in other words, we can express this as this section, or we can express it as a solution set. A solution set is written like this: as a solution set. This would be written as x being a real number for -3. Another thing we need to know that this inclusive or open circle is connected to either less or equal to, or greater or equal to that. And this open circle would mean either less or greater only. That's how they are associated. And so for this case, since we have a closed circle here, we are going to put that, then our x, then we include that 4, meaning we have a set of numbers from -3 up to -4 for all x being real, or a real set of numbers. And if we happen to include this, we can list them. We have from -3, since we have a closed circle, -3, that means -3 is included in the set. -2, -1, and 0, 1, 2, 3, and 4 is also inclusive, for in case this set is a set of integers, because for real numbers, it's you can't list all real numbers. You rather explain it as a solution set, or in grammatically as that. But for integers, integers are 1, 2, 0, and positive numbers and negative numbers as well. So, but now, in case, how about when we don't want to include numbers? When, let me say, we are still going to use that same number line. Excluding some numbers, and I still use that same case of the number line: 0, 1, 2, 3, 4, -1, -2, -3. Let's say a -2, but we don't want to include -2. And let me say at 4, but we want to include 4. We make it closed, and we just join those 2 points. We can, as a solution set, we can write this as set of x in are real numbers. For -2 with an open circle, we have this. So x is in between here. That means -2 is actually less than x. But since here we have a closed circle, the next thing that will be that or that, because x is in the middle here. That means 4 is actually greater than x. That's why x is less or equal to 4 due to this closed circle. That's basically what we can say about those open and closed circle. And in case we want to include or we don't want to include certain numbers or figures. And we also have another case here. We can make it be a note. Let me say we have certain notations. Let me say the notation or expressing a set whereby you're making x to obey some rule. X obeying some rule. That means actually your x is just obeying some rule that has been fixed instead of maybe having many other numbers in. Let me say, for example, we can have x in a real set for x not being 1. So in case we want to list these real numbers, which x in this real set, but we won't be able to include 1. Let me say we can list that as real numbers stretch from -infinity, let me say, to -3, -2, -1. Then we can include here 0, but we are not going to include. The rule is don't put -1. We are not going to put x should not be equal to -1. I mean 1. So we're going to skip 1 and go to 2, 3, and also continue the other side like that. That's some of the rules I'm talking about. And so this notation can also be fixed to some rule. That means x obeying some rule. Another thing we can maybe note there, sometimes for the case of there are some notations still under that note, we can have that another notation that we can include. Sometimes x can you can be given an inequality. Let me say that for x in a real set whereby x is less than a, this same solution set can also be expressed as x for x less than a, or can be simply that means this, or can simply be written as that. Whenever you see this or that, it would mean this, meaning that x, every time you see x just written a solution of an inequality or problem just written as this or that, it would mean, for that matter, we assume that our x is a real number or x is from a real set. And that's basically another thing that I wanted us to note. And I think we can now proceed. Maybe inequalities can also be simplified using a method. In case we know, since sometimes we can have our solutions in this form or that form, we just assume it's a real number. That means now we're going to look at some of the examples or some of the solutions. And as when solving inequalities, you need to know that it's just like solving any other any other equation which has no inequality signs, like less or equal, or less, greater, less or equal to, or greater or equal to. That means, but on the only difference is that we will be having, we may have a range, or we can have possible values which is not finite. Like maybe when you're solving a solution, you know you have a number, either have a number or two as your solution. But for this case, we might have a range of numbers, just like we had been seeing before here. We can have x between this, that one is lead, and sometimes let me say x greater than, let's say 4. You can, that means you're going to have x from 5, from numbers bigger than 4 onwards until no end, or until infinity. So that would be the major difference between solving inequality questions and maybe solving a normal equation. So for a normal equation, you have a fixed answer that you have to get, but for inequalities, you might have varying answers, or very many solutions to the problem. So we look at some examples. Let me say the first one. We can simplify. Let me say 6x minus 3 less or equal to 21 minus 2x. At first, we are just going, you first consider that to be like any equal sign joining this, just an inequality. So the first thing we're going to do, collecting like terms, we can collect x on one side and only figures the other side. So if you are to cross, let me say x this side, that means we're going to have 6x. For us to remove x from here and bring this side, that means we need to add 2x here and also add 2x here. 2x minus 3 less than equal to 21 minus 2x plus 2x. What we have done this side, we have done this side, so that we cause no change to the inequality. Means this negative and a positive will just cancel out automatically, so that we have here 8x. We take also 3 the other side. That means if we add 3 here, we also have to add the other side to remove the 3. We're going to have 21 plus 3 here, so that we have 8x less or equal to 21 plus 3 will be 24. Then to expose our x, we can divide throughout by 8. If we divide by 8 here, we're going to have x less or equal to, divide by 8 here, we're going to have 3. So you can see that for this case, we have only a set of solutions. We have only figures, big answers ranging from 3 downwards up to the negative side of infinity. That's why we say it's not fixed or infinite. So we can also express this as a solution set. Remember, we said that in case, for this case, x can just be in this format, so we just consider for that case our x to be a real number, or a real set of numbers. So as a solution set, we can write that as, that means we can either write as this or that. This, we're going to have x for x less or equal to 3, or x in R real for x less or equal to 3. This can also be written as this, and can also be written as that. And diagrammatically, that means using our number line, you can express that the solution set in a number line. We have 3, so 0, 1, 2, 3. Let me say 4, 91, 92, 93, 94, 95. We have the value is 3, but we have an equal sign here, less or equal to. And remember what we said, inclusive, less or equal to is associated with a closed circle, which means we include that number. So we are going to put a closed circle on top of 3, and now we stretch is going backwards. It's less than this. Sorry, line is not straight. So our set of solutions from there backwards. This line is supposed to be straight. So that's a set of solution. That's how we can simply solve that number. Now we are going to now see that only that we have another case. For this case, sometimes we solve this and we realize that we have to, let me say we have reached this point whereby we had to divide by 3. Now we had to divide by, let me say 8 was a negative number. For such cases, we always change this sign. Now that means for this case, this one will change to be greater or equal to. And I'm going to show you why. Let us first consider there are some cases we solve and reach a point of dividing through by a negative number. For that, we change our inequality sign. So let's look at a few cases. Let's consider the following. Let me say 4 is greater than 3. We have another one, 3 greater than -2. We can check on which other number can we. Let me say -4 less than -2. If you can see this scenario, we have 4 greater than 3, that's true. We have 3 greater than -2, that's true, and -4 being less, and +4 being less than +2, which is not true for all this case after multiplying by 91. But changing the sign, we will have this -4 less than -3 less than -2, and 4 greater than +2, which is true. That's the reason, basically the reason why we change sign after multiplying or dividing through by negative value. Now we look at some examples. The first one, let's simplify and show on a diagram. The first example we can look at is 8 minus 2x, that's equal to 3. And that's the first one. And we look at another, let me say -5 less than 2x plus 3, that's equal to 7. For the first case, we have 8 minus 2x less than or equal to 3. Remove 8 from here by subtracting both sides, equal to -5. So that here, if we divide throughout by -2, we're going to change the sign to become 5 out of 2, and 5 over 2 is the same as 2.5. If you see from here, goes in 2, then 4 here, remainder 1, 2 whole number, and 1 out of that of 2. And on a number line, we can show that diagrammatically. 0, we have 1, we have 2, we have 3, 4, we have -1, -2 this side. We have on 2.5, that's at this point, middle point of 2 and 3. We have a closed circle because of this sign greater or equal to, and it's greater means going towards the right. That's a solution of x. The second example, that is B. We're going to have 95 less than 2x plus 3 less or equal to 7. So that here we now subtract 3 on both sides to remove from the x. So that we have 95 minus 3 less or equal to 2x less or equal to -3. Here we have 4 minus 8 less or equal to 2x less or equal to 4. Divide throughout by 2, we have -8. -4 less or equal to x less or equal to 2. Then on a number line, we can see that it's going to be something like this. We have here 0, 1, 2, 1, -2, -3, -4. So that here we have, here on 2 we have a closed circle, and the same on 94 we have a closed circle because of the less or equal to sign, and join the 2 points. That's our solution on a number line. Now the next thing we're going to look at is a modulus. The modulus of a number is a sign. Let me say we can show that by modulus of x is written as that, meaning only consider positive sign of x. That's the same as size of x. So which is the modulus of x. So we look at this. So if we have -7, modulus of -7, we ignore the negative sign. So we come at 7. Let me say modulus of -3. That means it's going to be a 3. Modulus of a positive number will remain the positive number. And we can also have we can now just see that we can also make some note here that will help us. Modulus of a number less than a number means that x must lie between positive a and negative a. Now for the case of the greater, means that x must either be greater than positive value of a or less than negative value of a. And we're going to see that in this example as I show you how that comes about. Let me see an example. We have here, let me say a. We can think of a number, let me say -3 being less or equal to 7. Now to solve this, we are going to use this note that we have put. For case of less than, this also means is the same case for less or equal to. This also same case for greater or equal to for that case. Now for this case, we're going to consider that it means that when you see a less or equal to or less, must mean that it must lie between the negative and positive value of this. So we can put negative of this, less or equal to, we consider that side 2x minus 3 less or equal to, so it must lie between the negative value and positive value of that. So that means we're going to solve this. We remove 3 from here by adding everywhere, by adding a positive 3 everywhere, so that we have here, when we add 3 here, we have -4, so equal to, when we have 3 here, we have -2, we have 2x less than or equal to, we have 3 here, we have 10. So divided throughout by 2, we're going to have -2 less or equal to x less or equal to 5. And showing that on a number line, we're going to have here, let me say 5, 4, 3, 2, 1, 0, -1, -2, -3. We have here on -2 is closed because of the equal or equal sign. Then on 5, we also have a closed one. I can call this a first case of solving. I'm now going to show you the second case of solving, which is actually the basis that will show you how this comes about. And remember, this means we have just left the positive value. That means this number under between these bars has both positive value, the positive sign and a negative sign of it. So we consider both cases for that case. If you want to see how this comes about, so first case we consider positive. First we consider the positive of it being less than that. So that if we open that bracket, we're going to have 2x minus 3 less or equal to 7. We had 3 on both sides to remove from here, so that we have 2x being less or equal to 10. So that here we have dividing throughout by 2. We're going to have x being less or equal to 5. Then for another case, we consider it when it's negative. So that here we have minus 2x plus 3 being less or equal to 7. So that here now we subtract 3 on both sides, we have negative 2x less or equal to 4. Dividing throughout by negative 2 would mean we have to change our sign to greater or equal to negative 2. And that's why we came out with this. So when you combine that, you have negative 2 and 5 here, x in the middle. Then you put those. So, then we know that x is greater or than, then here is for the case of negative 2, x is greater, here we have less or equal to, here also less or equal to, because now we have that, because here we are seeing is greater, that's why x is in the middle, and here 5 is less, that's why x is in the middle. So the same thing we see there. So when you want to come to that, another way you can consider both sides. When this is positive and this is negative, you can still come with a solution and plot them on that number line. We're going to look at another example. Let me say now which number can we think of? Let me say b. We say negative. Let me say 3x plus 1 in the modulus. Now this time let's look at a greater one, which is, let me say 8. Solving that first case, you can see that we're going to consider a statement here to be our first case. For greater, it means x must either be greater than the positive value of a or less than the negative value of a. So we're going to consider that x should either be 3x plus 1, the whole of that, and everything under the modulus, plus 1 should be greater than the positive value. So that means we have 3x, subtracting 1 on both sides, we're going to remain 3x here greater or equal to 7. So that we have x being greater than 7 out of 3, which can be expressed in terms of mixed fraction. Just see to make us know the exact point on the number line. We have here 3. So it goes there 2 for 6, then 1. So it's 2 and 1 out of 3, greater than 2 and 1 out of 3. Or from the statement it says this, or less than the negative value of 8. So we have here 3x plus 1 being less than negative value of that, so that we have 3x, when we subtract from both sides to have remaining that less than negative 9. So that here we have x less than negative 3 if we divide that. Then plotting that on a number line, 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Here 2 and 1 means we have here 2 and 1 out of 3. That means between these 2 and 3 we have 3 sections, 1, 2 and 3. So at 1 out of 3, that's this point here. 2 and 1 out of 3, let me say here is an open circle, put there an open circle, then it's greater going that side. Then for the case of this, we have x less than negative 3, and it's also an open circle. We put that open, then it's less going that side to the negative for less. Then we see our second case scenario. Second case, that's when we consider the other one that I came up with, to see how you can come to that. We have here 3x plus 1 greater than 8. You consider the first positive side greater than 8. That means here positive, right? So that we open that, we see remain the same thing like that. so that we 8, I mean, sorry, it's 8, so that we have 3x greater than 7. We subtract 1 here to remove. We do the same the other side, so that we have 3 greater than 7 out of 3, which we saw as 2 and 1 out of 3 from up here. Up there, that's shadow there. Then, and we also consider the negative one, the whole of that. If you don't put the whole of that, you come with the wrong answer, because you would end up with a negative on 3, which will affect your result greater than 8. Now for this case, we're going to have negative 3x minus 1 greater than 8, so that we have here negative 3x minus 1 plus 1 to remove from there. Then we also do the same the other side, so that we don't cause any change to the inequality. We have the negative 3x being greater than 9, so that here we remain with x. After dividing throughout by negative 3, we're going to remain with, we're going to change our sign because of dividing throughout by negative, so that we have here negative 3. Then we see that that's the same thing we had there, so that we come out with the same thing. And that's basically all for today's video. Thank you for coming to my channel. Please like, subscribe and share, and